Alright, here we go. This is section 3.3. We are using the webpage mathplanet.com. You might want to write that down. All I did was go to Google and type in radical, graph of a radical, and hit images, and this one popped up, and I was able to go to this website, and it's pretty good. Okay, and we're going to use this. It's going to keep me from having to write out all these different ones. Now, just like cubics and just like parabolas, when we start out with these, I always like to do a very basic, come on now. I always like to do a very basic, why isn't it smart coming up? Is it red over there, or is it green?
It's green.
X.
It's red.
It's not going to let you write
on a web page? Normally, the little thing
you
comes
did yesterday, didn't you?
It's going to mess everything up.
Put a dot.
Well, let's go to...
There it is. There it is.
Oh, it just took it a while. Alright, so here we go. X. Yeah, there we go. Alright, X and Y. If we wanted to be very methodical, we could come up with a basic T-chart. Okay, first point that I would plug in would be 0. If I plug in 0 for X, right, I'm doing the graph of Y equals the square root of X. What is the square root of 0?
0.
That would be 0. Okay, that's why the graph starts off right here at 0, 0. Okay? What would be the next point that I would want to try?
1.
Let's try 1. Why is that nice?
Because 1 times 1.
1 times 1, right? We have a square root of 1. What is it?
1.
1. So the point 1, 1 would be on our graph as well. 1, 1 would be right here, it looks like. Okay? What would be the next point that would be nice and easy to graph?
4.
Why not 3?
Because it's not
Square root of 3 is a fraction, or a decimal. Okay? So 4 would be the next perfect square that I would want to try. Square root of 4 is 2. So here we go, 4, 2. So we're out to here. What would the next one be?
9.
9. What's the square root of 9?
3.
3. So here's 9 right in here somewhere, and 3 would be, I guess, right there.
Oh.
So here's the graph of y equals the square root of x. Okay? It goes on and on and on forever. All the way in that direction forever. Does it go in this direction ever?
No.
Does it go down anymore or to the left anymore?
No.
No, it does not. Because if I were to stick in a negative 1, right, what's the square root of negative 1?
Negative. Oh.
I. Come on, guys. What's the square root of negative 1? It's I. It's an imaginary number. Can I graph an imaginary number?
No.
No, I cannot. So the graph doesn't work. This domain and range are restricted. Okay? They start at 0, 0, and then it goes in that direction forever. So let's talk about that a little bit. We haven't ever really talked about a restricted domain and range. But I like that because it really tests whether or not you understand domain and range. Remember that domain are the x values. Range are the what? Y values. Okay, so let's think about domain. Here's this graph that starts at 0, 0, and it goes in this direction forever and ever and ever. And it never stops, and it keeps going, and it keeps going, all the way to positive infinity. Okay? How do we represent that? What would you say the domain is of this graph?
All real numbers.
No.
All real positive numbers.
X.
You're on the right track. It's certainly not all real numbers because it doesn't include any negative numbers. Right? I don't go in this direction ever. I start at 0 and I go in that direction forever. We don't say all positive numbers, but you're on the right track.
X is greater than or equal to 0.
We're in relation to x. What is it in relation to x? X, all these values are what?
Greater than or equal to 0.
Greater than or equal to 0. Outstanding. Very good. X, this case, is greater than or equal to 0. Why do we say x?
Because
We're talking about the domain, and domain always deals with x values. So we say x is greater than or equal to 0. Why is it greater than or equal to?
Because it could be 0.
Because it could be 0. 0 works, right? I can plug in 0 all day long.
But it can't
And
be
the
anything
outcome
lower
is
than
0.
0.
Say that again?
But it can't be anything lower.
Can't be anything lower than 0, because when I stuck in negative 1, I got an imaginary answer, and that doesn't work. Yes?
For radicals, will that always be the domain?
No, it won't always be the domain. Okay, good question. It will change. How about the range? The range, we talk about the y values. We talk about from this value and up and up and up and up forever and ever and ever. What is the range on this?
Y is greater than or equal to 0.
Much better. You guys caught on. Y is greater than or equal to 0. Starts at 0, 0, and it goes up and up and up forever. Now, to preview what we're fixing to do, what do you think how are we going to change the graph of y equals the square root of x? What are we going to do to it?
Add numbers.
We're going to add some numbers. Where are those numbers going to go? Give me some places where the numbers could go. Could I stick a number in front?
Yes.
Yeah, and that would change things. Could I make that number negative?
Yes.
Yes, and that would change things. Where else could I stick a number?
Inside the
Y
radical.
On the inside of the radical, right? I could put it underneath there. I could say x plus 2, and that would change things. Where else could I stick a number?
Y.
Could it be an x1?
I could stick it on the outside, right? I could say minus 3 on the outside. So just like cubics, I can change all of those things. The good news is it's exactly the same. I do all those things the same. It's just a little different. The graph, obviously, is a little different. Okay? We're fixing to go through all those different things. Horizontal shift, vertical shift, inverted, stretch and shrink. We're talking about all those things, but now we're talking about radicals. We're not talking about cubics anymore. Okay? We're now talking about y equals the square root of x. All right? Questions? Any questions? All right, let's talk about the first one. Let's see if this will turn off. Man, it's just, oh, there we go. All right, now let's scroll down. What's the first thing we're going to talk about? Stretch and shrink. All right, so here we go. If I change the number in front of the radical, in this case A, and A is greater than 0, then what do we have?
A vertical stretch.
We have a vertical stretch. Write that down. These are your notes. Coming right off this web page. Man, this is nice. I don't have to graph all of these. Alright? What about if A is in between 0 and 1? Then what do we have? A vertical shrink. Is that the same as cubics?
Yes.
Yes, it's exactly the same. I'd write that down. You need to know how that impacts the graph, though, and I'm fixing to talk about that. I'm giving you a chance to write this down. I'm going to talk about the graphs in just a minute. Yes?
I'll get back to you.
Okay. All right. So let's look here. What does the graph of y equals the square root of x look like? Where does it start? We just did it.
0, 0.
Starts at 0, 0, and it goes up and up and up and to the right like that. That's what it looks like. Okay, that's the basic, that's the parent graph, that's the one you should have memorized. If I change that number, okay, and we said if it's greater than 0, let's do an example. Y equals 8 times the square root of x. I'm making it really big. Okay, A is 8. Is 8 greater than 1? Yes, it is. What kind of stretch or shrink is this going to be? It's going to be a vertical stretch because A is greater than 1. All right, what's the graph going to look like? Well, let's think about it. Are we going to start at 0, 0?
Yes.
Yes, because there's nothing on the inside, there's nothing on the outside. All we're changing is that. So we're still going to start at 0, 0. But when I stick in 1, what's the square root of 1? 1. What's it going to then be multiplied by?
8.
8. So instead of 1, 8, instead of 1, 1, I'm now going to be at 1, 8. So when you have a vertical stretch, what it does is it really gets big really quickly. See over here? The blue is standard. The stretch, when y equals 2 root x, is up higher. So you might want to write this in your notes in the margin. A stretch means that it's going to be higher than normal. Normal is kind of in the middle. A stretch is higher. Okay? Because stretch, the word stretch really doesn't mean anything here. You can't use the rubber band analogy. Okay? Are you with me?
So shrink is...
Well, we're not there yet. What is stretch? If there's normal, where's stretch going to be? Above. Okay? The bigger that number, the higher that stretch is going to be. If you're confused, plug a 1 in. See what it is. Do a small T-chart in your head. Okay? Questions? Any questions? Alright, so here we go. Let's talk about vertical shrink. When do we have a shrink? When A is in between 0 and 1. So let's do an example. We'll do it right here on the same graph. I'll do it in a different color. Y equals, say, 1/2 root x. y equals 1/2 root x. That's how we say that. Don't say square root, just shorten it to root. Y equals 1/2 root x. Where is it going to start?
0, 0.
Why?
Because
Nothing on the inside, nothing on the outside. We haven't changed the starting point, so it's still going to start at 0, 0. Okay? I'll put normal in dots. Here's normal. There would be the square root of just plain old x. But if I add the 1/2 in front, I shrink it, and where is it going to be?
closer to
Below
the
that.
x-axis.
Very good. Very good description. It's going to be closer to the x-axis. It's going to be like this. Because put a 1 in there. What's the square root of 1? 1, and instead of being 1, you're going to multiply it by 1/2, and it's going to be down low. Okay? So, if I stretch it, to summarize this, if I stretch it, I put it up high. If I shrink it, I put it down low. Where's normal?
In the middle.
Kind of in the middle. 1, 1, 4, 2, 9, 3. That's normal. Okay? Questions? Any questions? Alright, let's move on down. The next thing we're going to talk about is what happens when I change A and I make it negative. What do you think is going to happen? Yes?
It's going to go the other way.
It's going to invert it. Let me ask you this. If normal, all these are normal and we're in quadrant 1, where do you think inverted might be?
Quadrant 2.
Quadrant 2, would it be going to the left or would it be in quadrant 4?
Oh, it'll be a quadrant 4 going
It'd be in
down.
quadrant 4. Still pointing to the right. Okay, here it is. Copy it down. Y equals the square root of x. There's normal. Quadrant 1, right there. If I change A to a negative number, we say that it is inverted, just like cubics. And it does everything exactly the same, but it's now inverted. I'm sorry, it's now in quadrant 4. It's now down below in quadrant 4. What's our time there, Marlo?
12 minutes.
Okay. Let me know when we hit 15. It's now inverted. It's now below the x-axis, and it's in quadrant 4. What's the only thing I changed there?
Negative.
A is negative. Not the turning point, the starting point, still at 0, 0. Everything else is exactly the same. Questions? Yes, ma'am.
When it's like that, how do you know the starting point?
Nothing on here. I'll do it here. Y equals negative root x. There's nothing here and there's nothing here. We hadn't talked about that yet, but that's where we're headed. If I put a number on the inside, what do you think that's going to change? Is that going to be horizontal or vertical? Horizontal. Very good. If I put a number on the outside, what's that going to change? Vertical. If I put a number on the inside, what do I have to do to it before I make my horizontal change? Very good. If I have a number on the outside, what do I have to do to it before I do my vertical change? It's exactly the same. Okay? Exactly like cubics. It's exactly the same. Okay? So you already know how to graph a radical right now. We hadn't even talked about it. Alright, questions? Any questions on it when I invert it? Yes? No. You're going to have to watch a video. Sorry, buddy. Here we go. Coming on down. You better write this website down. You better watch this video. If I change the number on the outside, here the blue is normal, y equals root x. If I put a number on the outside, that simply moves my starting point up 2. Okay? I'll do it over here. Y equals root x plus 2. Everything's the same. It's standard. I haven't shrunk it or stretched it. It's not inverted. All I do is instead of starting at 0, 0, I go up 2, and that's where I start. And there's my graph. Now we talk about domain and range. It gets interesting. Now you really have to understand what's going on. You have to really understand domain and range. That's why I like these problems so much. What is the domain on this problem?
Y is greater than
We wouldn't say y if we're talking about domain.
X is greater than or equal to 2.
Wrong.
0.
We start at 0, guys. We're talking about the x-axis. We're right here at 0. We're right there. We're starting at 0. How do we say that? X is greater than or equal to 0. See, that really tests whether or not you understand domain and range. You think your next quiz is going to have domain and range on it?
Yes.
Yes. Range. What is the range on this problem? You better be writing this down.
Y is greater than
Why?
or equal to 2.
Why do we deal with y when we're talking about range?
Because
range
it's the
covers
y.
all
Range
y
is talking about the y-axis, right? The graph starts right here and it goes up and up and up forever and ever. So how do we say that? Y is
greater than or equal to 2.
greater than or equal to 2. Perfect. Exactly right. Questions on that? Domain and range. Domain and range. Questions? Any questions? Yes?
So if it's positive, it goes up. If it's negative, it goes down.
If A is positive, then it's up. If A is negative, then it would be down. Yes?
So right now the plus 2.
Speak up. Shh.
Right now the plus 2 is outside of the radical.
That's right.
So
And
that
it's a
means
vertical shift. That tells us up and down. Correct. Exactly right. Yes, ma'am.
Will they ever go that way?
No, they won't. Good question. They can't go that way because that would be negative. Can't have negative numbers.
Oh yeah.
Okay? Yes.
Is x plus 2 all underneath the radical?
No, it's not. The only thing underneath the radical is the x. You'll know when it's underneath the radical. I'm fixing to do one. Alright, so now let's talk about horizontal shift. How are we going to horizontally shift it? We're going to put a number underneath the radical. If we want to move the graph left and right, we simply put a number underneath the radical. Here's an example. Y equals the square root of x minus 2. Y equals the square root of x minus 2. Okay? That gives us a horizontal shift. How much of a horizontal shift? How do we describe it? Is it going to be 2 to the right or is it going to be 2 to the left?
2 to the right.
2 to the right. How do I know that's right, though, when it's negative 2?
Because you have
You
to
do the opposite, just like cubic, just like parabolas, just like absolute value. The stuff on the inside, you do the opposite. So here's your graph. Okay, instead of starting at 0, 0, what do I do?
to go to the right.
I go to the right 2. And that's where I start. A is positive. Let's change it up a little bit. I don't know, I'm sorry if you've already graphed it. Well, let's put a negative in front. How does that change it?
It goes down.
Instead of being in quadrant 1, what quadrant is going to be?
4.
It's going to be in 4. Remember 1, 2, 3, 4. It's going to be down here in quadrant 4. Now let's talk about domain and range. Let's see who's got their A game. What is the domain? Think about it. Don't yell it out. Raise your hand if you think you know it. What is the domain on this problem? Nash?
X is less than or equal to 0.
You wouldn't say less than now. It's going that way. It's this number, it's 3, it's 4, it's 5, it's 6, it's all these numbers. X is
Greater than or equal
greater than or equal to how much?
2.
Positive 2. Doesn't include 1. Doesn't include 0. Doesn't include these 2 points. It starts at 2 and it goes in that direction forever. You better have these examples written down. How about the range on this problem? Tricky, tricky. Hold on. Carter. Less than or equal to 0. Outstanding. Very good. Okay. Less than or equal to 0. Why is it less than? Because it's all these values. It's down here in quadrant 4. Down, down, down. Okay. Questions? Any questions? Alright, let's see if we can put it all together. Let me erase this one. Let's see what we got. Y equals negative 3 root x plus 1 plus 2. Alright, that's as hard as I can make it. Okay? Crack the door, let her come in. He's sitting in your seat and I don't want you walking by the camera. Just have a seat back there near the fridge. How much time are we at?
18.
Ooh, stop it. That's going to take forever.